Evaluating functions. The introduction of function notation has made possible different ways to think about mathematics. One new thing we can do is represent the idea of finding the output, given an input. We call this procedure, this new procedure, evaluating a function. And we could do this before, it just looks different now and we have more information. It's a little nicer. When we're given some function, f of x, we evaluate it whenever we assign an input value for x, substitute it into the equation, and then determine the value of the output. Let's look at example 1. So, given that f of x is equal to 3x plus 6, find f of 2. So what we can do here is so 2 is going to be our input, and so we have f of 2 is equal to 3 times 2 plus 6. Well, 3 times 2, that's 6, plus 6. 6 plus 6 is 12. So what we have is that f of 2 is equal to 12. So right there in this statement, we have our input and our output. That's pretty nice. As functions become more complicated, they become harder to evaluate. But as long as we follow the order of operations, which is PEMDAS, we will get the correct answer. Let's look at examples 2 and 3. So example 2 here, given that g of x is equal to x minus 4 squared plus 3, find g of negative 1. So let's g of negative 1 is equal to the quantity, negative 1. Now I don't have to put this one in parentheses like I did above, because I'm just subtracting 4 from it. There's no multiplication or division or anything like that. Negative 1 minus 4, that quantity is squared plus 3. And negative 1 minus 4, that's negative 5 squared plus 3. Negative 5 squared, negative 5 times negative 5 is positive 25 plus 3. Now I'm going to bring this arrow up here. And I have g of negative 1 is equal to 28. So when the input is negative 1, the output of g is 28. The next one here, given that h of x is equal to 4 to the 5 minus x plus 7, find h of 3. So h of 3 is equal to 4 raised to the power 5 minus 3. Again, I don't have to put it in parentheses. I could if I wanted to. I just put it like that. There would be 2 sets of parentheses there then. So that's going to be 5 minus 3. So that's in parentheses. So we have to do that first, and it's in an exponent. So we have 4 squared plus 7. 4 squared is 16 plus 7. So h of 3 is equal to 23, because 16 plus 7 is 23. So when the input is 3, the output is 23. We can also evaluate a function when we are given a graph. We just need to remember that the input is the x value and the output is the y value. So we're going to look at a couple of examples here. Example 4. Given the function f, find f of 2. So what we need to do is look for the x value of 2, because that's the input, and we'll find the output, the y value. So we follow along here until we get to x equals 2, that's right here, and then the y value is negative 15. So when the x value is 2, the y value is negative 15. So f of 2 equals negative 15. Last problem here. Given the function k, find k of 1. So again, we look for the y value when x is equal to 1. Well, right here, this is where x equals 1, and there's the point, and it is 0. So k of 1 is equal to 0. It's right on the x-axis. And that is evaluating functions.